everyone, and welcome to our session on how to build more accessible UIs with Jetpack Compose. My name is Simona Milanovic. I'm an Android Developer Relations Engineer at Google.
And I'm Melba Nuzen, a software engineer working on Jetpack Compose.
Developing with accessibility in mind means making your apps usable by even more people, including those with accessibility needs, who may use Android devices in different ways. So, in this talk, we'll focus on how to leverage powerful declarative Compose APIs and tools to build apps that are more inclusive and accessible. We'll cover practical steps and concepts in supporting accessibility with Compose, starting with how to classify composables and modify them with the appropriate APIs and semantics. We'll also show how to inspect the composable semantics with tools that can be used for debugging unexpected behaviors when used with Android's assistive technologies. Finally, we'll cover how to detect common accessibility issues and automate some aspects of testing with Compose accessibility checks. By the end, you'll have the right tools and techniques to create more delightful and inclusive experiences for more users. For updates in Android accessibility, check out the linked IO talk. As the first step, it's helpful to classify your component, as this also impacts the level of modification of its accessibility information. A ready-made material component will differ in potential adjustments from a custom component. From an accessibility perspective, you can put composables into roughly 3 categories: material components, Compose Foundation and UI APIs, and custom components. These range from none to minimal semantic modifications for material to potentially larger structural changes for more custom components. This classification helps you choose and integrate more information into the UI elements earlier in the app development. This information on the meaning and role of a component that is sent to accessibility services is called semantics. For example, a camera icon might be visually just an image, but the semantic meaning could be take a photo. To learn more about accessibility basics ahead of this talk, check out the linked documentation and video. By combining the right semantics with Compose APIs, you provide as much information as possible about your component to accessibility services, which then decide how and what to represent to the user.
Let's look at each category, starting with material components. These pre-built UI elements include built-in semantics that follow their specific role and function, meaning that most accessibility support is provided for you with little or no additional work. For example, a material button might consist of a child icon and some text. Instead of treating the children as individuals, a material button merges its children's semantics by default so that accessibility services can treat them as one entity. Merging is a powerful concept in semantics and widely used, as we'll see later. But in general, material components require little adjustment in order to be more accessible when used for their intended purpose. Similarly, in Compose UI and Foundation APIs, many accessible practices are also followed by default. Using the right APIs for the right purpose usually means you get predefined semantics that cover standard use cases, but you should double-check that these defaults fit your needs. If it isn't enough for some cases, Compose also provides the tools to adjust for more specific requirements. Most semantic properties are a way to simply provide additional information. Setting something like a content description or a state description provides more metadata about a UI component to services that consume semantics. But some semantics require more careful consideration since they can influence how the structure of a screen is interpreted, rather than only provide additional helpful information. 2 Compose APIs are specifically meant to support accessibility traversal order. When using composables with predefined semantics, there could be a need to modify their traversal order, or the order in which accessibility services navigate through UI elements. By default, Compose arranges elements in expected reading order, usually top to bottom, then left to right. While this normally creates a logical order, there are some scenarios where top to bottom, left to right is not sufficient, and Compose might need additional hints. In these cases, you can use Compose's isTraversalGroup and TraversalIndex APIs. IsTraversalGroup marks logical semantic groups that need customization, while TraversalIndex adjusts the order of individual elements within those groups. Let's look closer at the clock face example. The UI consists of a circular layout where the numbers of the clock are placed, and some clock text containing the actual number values. To influence the default traversal order, we set isTraversalGroup equals true on the surrounding parent, in this case, the circular layout. Then we assign increasing traversal index values to each child element so that they can be numbered numerically. To influence traversal behavior, this API must be set on a component that will be selectable by accessibility services. In this case, we set the index on the text itself rather than the containing box parent. With those changes, we've adjusted our traversal order to be more logical for accessibility services. As you apply these APIs, here are some things to keep in mind. Is traversal group equals true should be set on the parent containing the grouped elements. Traversal index should be set on a child component that contains semantics and will be used by accessibility services. And no semantics are unnecessarily merged, as this may affect which components traversal indices are applied to.
Foundation APIs that make your composable clickable, toggleable, or overall interactable use the same merging strategies as the material button, which merges its children semantics by default. Using the clickable modifier makes that composable merge its descendant semantics into a single entity, which then gets represented together by the accessibility services, along with the corresponding action representation. You can also set the onClick label in the parent clickable to provide additional information to accessibility services and offer a more polished representation. For this modifier and its click label, using TalkBack as an example, it would provide an action hint of double tap to open this article, rather than the generic default of double tap to activate. This feedback changes depending on the action type. So, a long click would provide a TalkBack hint of double tap and hold to, usually followed by a verb label. In cases where you don't have direct access to a clickable modifier, for example, if it's set somewhere in a lower nested layer, but still want to change the default action label, you can split setting the clickable action from modifying its semantics. You can do so using modifier semantics and its onClick label to modify the action representation there. In this case, you don't need to pass the click action twice, as certain Compose APIs, like Clickable, handle this for you and pass it down to their intrinsic clickable semantics. You might run into scenarios where you expect children's semantics to be merged into the parent one, but that doesn't happen. In this example, we have a clickable parent with 3 children elements, and we might expect it merges all of them. However, some composables would not automatically merge under a parent by design. A parent cannot merge its children when the children are also merging, either from explicitly setting merge descendants to true or by being components which merge themselves, like buttons or clickables. Knowing how certain APIs merge or defy merging can help you debug unexpected behaviors. Custom actions can sometimes help improve the user experience of accessibility services. Complex touchscreen gestures like swipe to dismiss or drag and drop can be challenging for users with accessibility needs, so custom actions can be used as a more accessible representation. For example, to make the swipe to dismiss gesture more accessible, you can link it to a custom action, passing the dismissal action and label there. An accessibility service like TalkBack would then highlight the component and hint that there are more actions available in its menu, representing the swipe to dismiss action there. This only changes the swipe to dismiss for accessibility services. You can still use the original swipe gesture. In long lists, with items that have multiple available actions, it might be tedious for users to iterate through each action for every single item individually. To improve the navigation experience, which is especially helpful for interaction-based assistive technologies like switch access or voice access, you can use custom actions on the parent item and move its nested actions out of the individual traversal and into a separate action menu. Using switch access as an example, its menu opens on selecting the parent item, offering the available actions there. However, make sure to always clear the original semantics of items which actions you're moving elsewhere. We'll see more on this later.
So far, we've covered composables with some predefined semantics, but what if you're building your own custom component? As a general rule of thumb, it can be helpful to see semantics of similar components in the material or other Compose libraries. But another tool we can use is manual semantic merging. If your custom component consists of multiple elements, you can manually join their semantic information to treat the component as one entity. This is done by setting modifier.semantics merge descendants equals true. Under the hood, merging components like a material button and modifier.clickable or modifier.toggleable set this flag to true as well. Setting this API collects and combines data from non-merging children, as merging won't apply to any children that are merging themselves. Let's look at an example of a custom avatar component. We have 3 parts: an avatar image, a status overlay, and a profile name overlay. As is, accessibility services see each part separately. But it would make more sense to consider the entire avatar component together, rather than treat each element individually. To do this, we set merge descendants equals true on the box containing all 3 elements. Then the component is grouped accordingly. But what about times where we don't need to send semantic information? In some scenarios, certain elements should not be sent to accessibility services, perhaps because their additional information is redundant for accessibility, or because they are purely visually decorative and non-interactive. In these cases, you can hide elements with the Hide from Accessibility API, introduced in Compose version 1.8. In the following examples, we see decorative components that can be hidden: a redundant watermark that spans a box, and a character used to decoratively separate information. Using Hide from Accessibility here ensures that these components are hidden from accessibility services, but still retain their semantics for other purposes like testing. However, if semantic information must be completely cleared or overwritten, then a more powerful API to use is clear and set semantics. When a component needs its own and its descendant semantics cleared, use this API with an empty lambda. Note that when clearing with an empty lambda, the cleared semantics are not sent to any consumer, such as accessibility, autofill, or testing. When semantics must be overwritten, include your new content inside the lambda. When overriding content with new semantics inside the lambda, the new semantics replace all previous semantics of the element and its descendants. Let's look at a favorite toggle example, represented by an interactable row with an icon and some text. Although the icon and text have some semantic information, together they do not indicate that this component is a toggleable. Merging alone is not sufficient, since we must also set the toggle ability, as well as role and state semantics, so that component status and associated action may be available. For example, TalkBack would announce double tap to toggle rather than double tap to activate. By clearing the original semantics and setting new, more descriptive ones, accessibility services can now see that this is a toggleable component that can alternate state. Some things to remember. Since services receive no semantic information when this API is set, it's better to be conservative about its use. Semantic information can potentially be used by AI agents and similar services to understand the screen, and thus should only be cleared when necessary. Custom semantics may be set within the API lambda. And lastly, ordering of the modifiers matters. This API clears all semantics that are after where it is applied, regardless of other merging strategies. Note that in our sample, since clear and set semantics is set after the clickable modifier, the clickable semantics are not cleared. We've covered quite a few APIs and concepts. To recap, when content is not intended to be used by accessibility services, use Hide from Accessibility when it is possibly decorative or redundant, but still must be tested. Use clear and set semantics with an empty lambda when parent and children semantics need to be cleared for all services. Use clear and set semantics with content inside the lambda when a component's semantics need to be manually set. And when content should be treated as one entity with all children information needed to be considered complete, use merge semantic descendants.
To specify and signal the content type of your custom component, you can use a variety of semantics. Content type semantics support the main semantic information, for example, the text of a text composable, and help accessibility services fine-tune how the component is represented, announced, or interacted with. For instance, if your component is an alert or a pop-up like a snack bar, you might want to signal to accessibility services that a new structure or updates to content should be conveyed to users. Alert-like components can be marked with the live region semantics. This allows accessibility services to automatically notify of changes to its component or the children. Polite mode should be used in most cases where users' attention should be drawn to alerts or important changing content on screen. Assertive mode should only be used sparingly to avoid disruptive feedback and should be reserved for when it's crucial that users are aware of time-sensitive content. Live regions should not be used on content that updates frequently, such as countdown timers, to avoid overwhelming users with feedback. Window-like custom components, similar to modal bottom sheet, need additional signals to differentiate them from surrounding content. For this, you can use the pane title semantics, so that relevant window or pane changes are represented appropriately by accessibility services, along with its main semantic information. Screens with a lot of textual information, like long articles or news, are usually divided into different subsections by using headings. Some accessibility services, like TalkBack, allow for easier navigation directly between sections or headings. To enable this, indicate that your component is a heading by defining its semantics. For other content types, such as arrow-like components, you might want to expand on the main semantic information for users with accessibility needs. When defining the arrow states, you can inform the accessibility services of its arrow semantics and provide expanded arrow messaging. In this example, TalkBack would hint the main arrow text, followed by additional expanded messaging. For custom components that track progress, you might want to notify users of its progress changes, like the current progress value, its range, and step size. You can do so with progress bar range info. This ensures that accessibility services are aware of progress changes and can update users accordingly. Different assistive technologies may have unique ways of hinting increasing and decreasing progression. In custom lists and grids with many items, it might be helpful for accessibility services to also have more detailed information, like the total number of items and indices, in addition to their main semantic information. By using collection info and collection item info on the list and items respectively, and TalkBack as an example, in this list, the service announces the total number of items, each item's textual information, and its items index out of total. There are a number of tools that can help quickly inspect the content from an accessibility point of view. Using the Android Accessibility Suite, which includes Accessibility Menu, Select to Speak, and others, provides insight into how your app works for users of these technologies. Testing with these assistive technologies is highly recommended as the best way to understand the experience of app users with accessibility needs. Layout Inspector allows you to inspect and debug semantics of composables and helps identify any missing or incorrect information. The Accessibility Scanner app scans your screen and provides suggestions to improve its accessibility by identifying some common pitfalls.
Between Compose, the semantic system, and Android accessibility services, you might run into unexpected accessibility behaviors that are difficult to trace. But there's a good chance that semantic properties can help you understand why your components are behaving the way they are. You can debug with a tool of your choice, from Layout Inspector in Android Studio, to Tree Debug in TalkBack developer settings, to Compose test rules print to log. These tools provide information about nodes and their properties that are exposed to accessibility services by Compose. As an example, let's take a look at Layout Inspector. What if you had a screen with 3 elements, but with accessibility services on, the first one wasn't being selected, and the second one didn't have any action feedback associated with it? We can examine the semantic properties to see if there's anything suspicious. The component tree in Layout Inspector contains information about an element's bounds, parameters, and semantic properties. In our tree, we see all 3 elements. But the first one has a hide from accessibility applied. That can help us debug why it isn't being selected. Maybe the element is marked as hidden somewhere in the semantics tree, or Compose considers it obscured because of some decorative overlay. The second element has a focus property, but no onClick like the previous element. So this element is probably missing a clickable modifier somewhere, which is why an accessibility service like TalkBack may not announce an action signal to the user, like double tap to activate. If we look at the third element, it has all the properties we want. It is focusable, has an onClick, and other additional semantics are applied, which is why it's interpreted as expected. In this way, debugging tools can help investigate why certain announcements or selections aren't happening with your accessibility services. Much of what we covered today can be manually verified, for example, by turning an accessibility service like Switch Access on and checking that all works as expected. However, in conjunction with manual verification, you should also use automated testing to flag any potential issues that could impact user experiences. Existing testing APIs in Compose allow you to write automated tests that interact with semantic elements and to assert properties defined in your UI. But you can now use the Accessibility Test Framework, the same framework underlying Accessibility Scanner and accessibility checks in Espresso to perform some checks automatically, starting with Compose 1.8. To do so, add the UI test JUnit 4 accessibility library to use accessibility checks. To enable them, call Enable Accessibility Checks in the Android Compose test rule and trigger an action or try perform accessibility checks. This specific test fails with an exception and a message that the item may not have a label readable by accessibility services. Other checks can look for color contrast, touch target size, or elements traversal order. In combination with manual testing, automated tests that use both Compose APIs as well as the accessibility test framework can help detect possible problems early on in the development lifecycle. We've covered a lot today, from classifying composables for accessibility to understanding when and how to set certain semantics to exploring how to test and debug components. We hope you've picked up a few more tips on how to make your Compose app more inclusive and how to unlock delightful experiences for even more users to enjoy.
Knowing when to add just a quick content description to an image or a larger set of semantics for a custom component means you're helping accessibility services better present your component, leading to a better app experience for accessibility users. If you want to dive deeper into Compose accessibility, take a look at our newly added guidance, link in the description. Thank you for being a part of an ecosystem of highly accessible, inclusive apps. Happy coding!